Hi, my name is John Krockmalny, and I've developed these visual tutorials to accompany any technical training format that might be delivered. In this presentation, we'll explore voltage, what it is, and how it does relate to electrical physics. We will also review how voltage is measured with electrical test instruments. There are three learning outcomes associated with this presentation. Number one, describe electrical voltage. Number two, identify three terms associated with electrical pressure. And then number three, describe how voltage is measured in electrical circuits. Energy is needed for anything to move. When a force is applied to an object, displacement can happen. When a force results in a movement, we can then say work was accomplished. When referencing mechanical work, force is measured in pounds. These pounds of force are applied over a surface area. The typical measuring term becomes pounds per square inch, or PSI. In this graphic, we see 1 cubic foot object weighing 10 pounds, creating a footprint which measures 12 inches by 12 inches squared. Multiplying 12 inches times 12 inches, the area of this footprint becomes 144 square inches. Laws of physics state that the weight of an object, 10 pounds in this case, is spread evenly over the entire footprint. Each square inch of the footprint will have 10 pounds of force on it. If there is 10 pounds on every square inch of the 144 square inch area, we can state that 10 pounds per square inch exists, or 10 psi. PSI, or pounds per square inch, becomes the term for measure in the United States for pressure. If energy cannot be created nor destroyed, but can be converted from one form of energy to another, we can start our understanding of electrical physics with fluid power circuits. In this graphic, we have a water hose open at both ends and exposed to atmospheric pressure. Atmospheric pressure at sea level is recorded at 14.7 psi. Notice that the left side of the hose has the same pressure applied to it as on the right side. Notice also that under this condition, water levels on both sides are at the same height. On this graphic, we can see an increase of pressure in psi on the left side and a decrease of pressure on the right. That on the right is 0 psi. This shows a pressure difference between one side and the other. 120 psi on the left and 0 psi on the right equals a pressure difference of 120 psi. With more pressure existing on the left leg than on the right, the result will be a flow of water. Notice that under this example, the water will flow from the greatest pressure to the lesser. In this graphic, from left to right. If we reverse the pressures, 120 psi on the right and 0 psi on the left, the flow is reversed. As we can see, the flow will travel from right to left. Again, reversing the pressures, 120 psi on the left and 0 psi on the right, the flow travels from the left to the right. Realize that referring to the graphic, it would be impossible for the flow to travel from right to left. Therefore, we can say that any flow will always travel from the highest pressure to the lowest. Using the same fluid power circuit, a water wheel is dropped in the center. We may now see that this water wheel will spin with water flow. The water wheel becomes a load in the fluid power circuit. A load is a component that converts one form of energy to another. In this example, the energy of the power of the fluid is converted into rotational mechanical torque and then can do work. Applying a pressure difference in the fluid power circuit and then resulting in a flow of fluid then powers the load, in this case a paddle wheel, which could be coupled to a millstone to do such work as the grinding of grain. With more pressure on the water circuit's left side compared to the right, the paddle wheel spins counterclockwise. More pressure on the water wheel's right side circuit causes the paddle wheel to spin clockwise. All that is necessary for the paddle wheel to spin is any difference in pressure and the resultant flow of fluid. This graphic shows a pressure difference of 120 psi. 120 psi is applied on the left and 0 psi on the right. This initiates a flow that travels from the highest pressure toward the lowest. We may also be able to imagine that the resultant spin of the paddle wheel to be fast. In this graphic, we increase the pressure on the right side of the water circuit, with 120 psi existing on the left and 60 psi on the right. The new pressure difference is 60 psi. The pressure difference is found by subtracting the greater pressure from the lesser pressure. Under this condition, and due to a decreased flow rate, we can imagine the paddle wheel to be spinning at medium speed. In this slide, we have increased the right side pressure to 119 psi, while keeping the left side at 120. This results in a pressure difference of 1 psi. Under this condition, the paddle wheel still spins, but at a slower rate. Here we see that 120 psi exists on both sides of the water circuit. Under this condition, there is 0 pressure difference. Also notice that there is no flow happening in the circuit, stopping the paddle wheel. It is important to understand that the reason the paddle wheel is not spinning is not because of lack of pressure. We see 120 psi at both ends of the water circuit, but if there is no pressure difference, there will not be any flow. We can now conclude 3 things about pressure difference and the resultant flow rates. For every increase of pressure difference, there will be an increase of flow rate. For every decrease of pressure difference, there will be a decrease of flow rate. If there is no pressure difference, there will be no flow. As mentioned at the beginning of this presentation, pressure difference is measured in psi, or pounds per square inch, and is needed to initiate a flow. Flow in the United States of America is measured in gallons per minute, or GPM. It is important to understand that GPM is really one value referring to 2 conditions: quantity in gallons and time in minutes, thus the gallons per minute term. Gallons per minute determine the quantity and rate of delivery of the flow of the material. We can measure pressure differences using a differential pressure sensor. Notice that when measuring with this type of instrument, 2 locations have to be sensed: the higher and lower pressure sides. The value on a meter records the actual pressure difference between these 2 points. As mentioned at the start of the presentation, if we can convert one form of energy to another, we can use the same analogies in other energy forms. In this case, we apply the same understanding to electricity, but we have to change the terms. The electrical term for pressure is voltage or volts. We still need a difference of electrical voltage pressure to initiate a flow of electrical energy. An electrical test instrument called a multimeter can be placed between 2 points of a circuit to measure voltage pressure differences. In this case, 120 volts on one side and 0 volts on the other results in a meter measurement of 120 volts of pressure difference. The electrical term for electrical flow is identified as the ampere or the amp. Amperes, like GPM in water circuits, is one value referencing two conditions, quantity and units of time, which is indicative of a flow of a material. Electrical pressure differences is needed to initiate a flow of electricity. This electrical pressure has three terms commonly used in the electrical industry: voltage, electromotive force, or EMF, and potential. The term voltage is used by electrical tradesmen and consumers. When people purchase batteries, they buy according to voltage or electrical pressure. Scientists and engineers use the term EMF, which stands for electromotive force. Old timers who may have learned the electrical trade from other old timers may use the term potential. Whether one uses the term of volts, EMF, or potential, realize that these all refer to the force of electrical pressure and that there needs to have a difference in this pressure to initiate an electrical flow in amps. In this graphic, a multimeter measures 120 volts across a circuit between L1 and N. This measurement could be indicated on a drawing with the letter V for voltage or E as electromotive force. Multimeters are electrical test instruments that can measure for various properties of electrical physics. For example, multimeters can measure circuit voltage, resistance, amperage, and continuity. When multimeters are configured to read voltage, the meter is placed in parallel to the power source or the load being measured. In this graphic, the meter is placed across the L1 and N terminations. In this graphic, the meter is placed across the battery terminals to measure the voltage of its charge. It is important to understand that at this point, there are two types of voltages: alternating current voltage and direct current voltage. These will be covered by another presentation. Another electrical test instrument that you could use could be a voltage detector. These types of instruments do not measure voltage values. Voltage detectors can only provide information on whether voltage is present in the circuit and not the voltage numerical value.